Hello, my name is Julio Gonzalez, UTCID GCW 925, and today we will be going over LabVIEW Homework 1, and the objective of this assignment was to design a program or a VI that will calculate the junction capacitance for a silicon PN junction when you're given parameters. So these are all my parameters, and they've been entered here accordingly to my front panel. And my front panel just shows you the surface level of the program. Um, and underneath it is the block diagram. So this is actually what makes the front panel show values here on your indicators. Once you enter in this VR user input value, which it should not be positive, so it has to be negative. Um, so let's go through my program and we can just kind of methodically go through it real quickly. So I just started from left to right to get my BI because that's what I need to find first in order to calculate the junction capacitance, the built-in potential, the voltage. So I just started with K, which, to get my to get my VT right here, did my K, then my T, I multiplied those together just like it shows here. Then I divided it by the E value. And then after that, I just had an indicator to show me, okay, this is what my VT value is. So it should be approximately this when you have this, um, when you have this absolute temperature, that's what it should equal. So I was like, okay, you're going in the right, direction. Um, and then after that, I did what's in parentheses here. So I did my NA times my ND, and then that was divided by my NI squared, just like it shows here. And then you multiply that times your LN, just like it. And then after that, you just multiply this VT value that you get right here times that value that you get here. And then that's how you achieve your VBI value. And once you have your VBI value, that's how you can calculate your junction capacitance. So then after that, I started with this, calculating this because it's under square root um, in the denominator. Um, so I just did my VR, which is the user input value, divided by the VBI value that we just attained. Then we did a 1 minus that. So as long as your order of operations is correct, you have it going in the right, um, to the right uh, input, you will get the correct value. So after I did that, my 1 minus this value, I just squared it. And after that, I just sent that value to be um, to divide my CJ naught value, just like it shows here. And that's how you attain your CJ, which is your capacitance value. So we can go through some values really quickly. So it has to be a negative value essentially. So we can do negative 10,000. Should give us a value here. So this is showing basically approximately. So yeah, it's approximately that. Um, That'll change if you have a different absolute value. Um, so yeah, we can go to -1. Also gives us the value, but if we go up to 1, it's a positive number, it does not compute. Um, to a really high number or just a really any positive number should not give you anything. So um, this should give us a value because it's negative. Um, so yeah, that basically shows you how to get your junctions capacitance of a reverse bias p-n junction with this program.